Today's webinar, the HOD of Department of Chemistry, Dr. Arunima Sharma Madam, IQAC Coordinator, Dr. Ranjit Kalita Sir, and all the participants. I feel privileged to share that the Department of Chemistry, Morigaon College, has organized the webinar in the fonding memory of our beloved late Puspa Mahanta Sir, the former HOD of Department of Chemistry, Morigaon College. Now, the topic of today's webinar is Hydrology and Sustainable Water Resource Management and Overview. We have scheduled the webinar in different sessions. Now, first of all, I request our respected Principal Sir kindly to deliver the welcome address.
Thank you.
Sir.
Thank you, Swagata. Good evening to all of you. Honorable Professor Jugen Chandra Kalita Sir, President Morigaon College Governing Body, and Professor in charge of International Relations Office, Guwahati University. Honorable today's resource person, distinguished scientist, Professor Mithan Lal Kansal, IIT Roorkee, Water Resource Development and Management, Head of the Department of Chemistry, Dr. Arunima Sharma, and other faculty members of the department, my respected teachers, scholars, students, I am very happy and grateful to you for joining this evening event. It gives me great pleasure to welcome you all to this national webinar in memory of our beloved and respected colleague, let Puspa Mahanta on this topic, on the topic hydrology and sustainable water resource management, an overview. And I think this is a novel endeavor of the department. I am very happy that the department has organized this type of webinar on such vital and important issues. I am extremely delighted for imparting me in this webinar, and I offer my sincere thanks to the Department of Chemistry for organizing this webinar, and it is an academic activity of the department. I hope that this activity will impart sustainable water development management, and this webinar will be very profitable for the participant. And now, on behalf of institution, I offer my sincere regards and heartfelt gratitude to the eminent resource person, scientist, Dr. Mithan Lal Kansal, for accepting our invitation and giving his precious time by attending this webinar despite his busy schedule. I hope today's webinar definitely be profitable and for all of us, and it will increase our knowledge on all dimensions of the topic. Now I want to thank our governing body president for his constant encouraging word and support. Finally, I express my deep gratitude to all the participants, scholars, and my students. I hope the participants will be enriched with a lot of knowledge out of the deliberation of the resource person. With these few words, once again, I warmly welcome you all. Thank you. Thank you all.
Thank you so much, sir, for your valuable speech. Now I request Mr. Mudit Jain to offer a tribute to former HOD Puspa Mahanta, sir.
Am I audible?
Yes, yes.
Yeah, you are audible.
Puspa Mahanta sir was born on 1st of March 1965. He joined our Department of Chemistry, Morigaon College, on 11th January 1996. He did his master's from Guwahati University with physical chemistry as his core field. Puspajyoti sir had a very kind and profound personality, and this personality reflected in his communication with the students. He was a down-to-earth person, and thus this made him the first person that anyone in the college thinks to consult with during a problem. His ease of handling the situation was unparalleled. Puspajyoti sir taught us not only physical chemistry, but which was present in our syllabus, but also all the scientific exploration that were taking place around the world. For me personally, Puspajyoti Mahanta sir has a special place. I made him not only to clear my doubts on physical chemistry, but also I approached him uh, to clear all my doubts about my life actually. To take all the important decisions, I used to consult him. He handled them so easily. So it was him. He was a very active person, and he was active in all kinds of co-curricular activities like college week, departmental seminars, webinars, and so on. He left this good word. He left behind a treasure of memories, which I personally will always cherish in my life. Thank you, Pusuri sir, for all that you did for our department and for this college as a whole. May your soul rest in peace. Thank you, everybody.
Thank you so much, Mudit.
Ma'am.
Now I request our HOD, Dr. Arunima Sharma Madam, to give a brief introduction of our resource person, Professor M.L. Kansal sir.
Okay. Hello, friends. Myself, Dr. Urnima Sharma, HOD Chemistry, Murigaon College. Today, Department of Chemistry, Murigaon College organizes a national webinar on the memory of our beloved colleague, late Puspajyoti Mahanta, who left us on 3rd June 2021. Respected the President of GB Murigaon College, Professor Jogen Chandra Kolita, Guwahati University, the Principal, Murigaon College, Honorable Professor Mithalal Kansal, Professor IIT Roorkee, my colleagues, my dear students, friends, research scholars from various institutions with us from abroad also. Very good evening to all. It is a very great pleasure to me to introduce Professor Mithalal Kansal, who delivered a very interactive speech on hydrology and sustainable water resources management and overview. Dr. Mithan Lal Kansal, currently working as a professor IIT Roorkee. He has served as head of the Department of Water Resources Development and Management, NEPCO, JPSS Chair Professor, and ADOSW at Indian Institute of Technology, Roorkee, India. He is a civil engineering graduate with post-graduation in water resources engineering. He obtained his PhD from Delhi University, India, and holds the postgraduate diploma in operation management. Previously, he served at Delhi Technical University, NIT Kurukshetra, IIT Delhi, and NIH Roorkee at various levels. He has published about 170 research papers, 2 books, and edited 6 books also. He is recipient of Visiting International Fellowship of EWRI of ASCE USA in 2021. He has got Best Paper Awards from Indian Building Congress, Indian Water Works Association, and received Star Performer Awards from IIT Roorkee. He acted as a reviewer for several international journals and research agencies. He has visited various countries as international experts and visiting professor. Dr. Kansal acted as international expert for RCUWM of UNESCO and IUCN, etc., and has worked as principal investigator for several international, 7 national research and consultancy projects. He has worked as executive vice president of India Water Resources Society and served as expert panel member for All India Council of Technical Education, India. Welcome, sir. Thanks to all. Now I have requesting Dr. Sagota Borua to continue the event.
Thank you, ma'am. This is the time I request Professor M.L. Kansal to deliver the speech we all are waiting for.
Thank you, Professor Sharma, for inviting me for this memorial talk. Thank you, Dr. Swagta Barwa. I pay my respect to the President GB, Professor Jogen Chandra Kalitha, under whose guidance this college is working and you are organizing this program. I'm thankful to Dr. Leela Kanta, principal of the college, that who has given so kind words, and he has invited me for organizing this event. And moreover, I'm thankful to all the participants who are present here this evening. I'm finding almost 200 people are there for attending this program. So this speaks the importance of this topic. And personally, I'm thankful to Moregaon College, particularly the chemistry department. I know they have been working very hard. I think this is one of the very good college probably in Assam, and particularly the chemistry department is a wonderful thing which they are doing in this particular area. So I'm quite impressed the way they are organizing, and I visited long back, maybe 9 years back, I visited that college. I was very impressed, and particularly the sincerity and the hard work of Professor Arunima Sharma. I really respect Madam Arunima Sharma for this. Thank you, Madam, for giving me the chance to present this topic. And I'm particularly thankful. I pay my homage to Dr. Puspa Jyoti Mahanta, in whose memorial we are gathering today and talking about that. May God give the place in his feet for the departed soul, and we pay our homage to the departed soul. With these words, let me share my screen and let's discuss the issue which we are talking about. I hope you can see my screen.
Yeah, sir. Yeah. We can
Okay.
see.
Thank you. So today we shall be discussing about the hydrology and sustainable water resources management and overview. So as we all know that the water is a basic necessity of our life, and that is why the most of the civilizations have developed on the banks of the water bodies, whether it is a river or a lake or any other type of the water body. So the civilizations have developed on the banks of those water bodies. The water we need basically for drinking purpose, for eating purpose, that is for food production and for preparation of the food, or for energy purpose, right? And as a part of the responsibility in the government or towards the society, we have to make a fundamental promise to our people that the water they drink and food they eat are adequate and safe. And it has been noticed that the almost 80% of all disease and over 1/3 of the deaths in developing countries are water associated. And on an average, as much as 1/10 of each person's productive time is sacrificed to water related problems. Like food security, providing water security in terms of the safe and adequate water availability, and healthy environment to all living beings is a fundamental duty of any government. So beside these, we need the energy in almost every sphere of life, and hydropower, which is a renewable and clean source of energy, is an important source of energy. So this speaks the importance of water in our life. The first thing which we are talking is the technical term when we are talking about hydrology, and as the topic also says about the hydrology. So if you basically understand the meaning of the hydrology, is basically it is made of two words, hydro and logy. The hydro means water and logy means the science. So therefore, it is a science that encompasses the occurrence, distribution, movement, and property of waters on the earth and their relationship with the environment. The hydrological cycle basically is a continuous process as water moves and gets purified from the earth's surface including the oceans, to the atmosphere and back to the land and ocean. I can just show you the water cycle. You can just see that typically in the water cycle, we have the different processes like the evaporation, precipitation, stream flow, evapotranspiration, infiltration, groundwater flow, and so on. Basically, from the oceans, the water gets evaporated, which form in the form of the clouds. They move the clouds on the towards the Earth's surface. Then the precipitation is caused, and that after the precipitation, the water either it moves on the surface or through the subsurface flow, and then ultimately again joins the ocean. So this is a complete cycle, and in this cycle itself, we have number of processes. So we should try to understand these processes, particularly the students who are science students. They will appreciate that the hydrological cycle or the water cycle is a very important aspect of our life. The water problems are concerned to almost all spheres of our life, whether they are meteorologists, oceanographers, geologists, chemists, physicists, biologists, economists, political scientists, specialists in the applied mathematics or computer science, or the engineers in the various fields. So it is not limited to one area. I mean, almost all spheres of the people are involved in the hydrology. A water professional dealing with any aspect of the hydrological cycle should understand all the physical, chemical, biological processes involving water as it travels through the atmosphere, over and beneath the Earth's surface, and through growing plants. So if you see the land system, that we have the precipitation, and precipitation falls through a structural system, it passes through the Earth system. The second is precipitation goes through the vegetation system, or the precipitation goes to the soil system. So through this vegetation system, the water goes as a evapotranspiration, or from the soil system, it goes as the evaporation, or the even structural system like the dams, etc. It goes, or the reservoirs, etc. It goes to the evaporation. Some part of that goes in the interception, or some part it goes from the soil system to the depression storage, or even there can be some through flow from vegetation system to soil system, or from soil system to vegetation system, right? So this is the land system related with the water. For example, if we go in the precipitation, some of you, the question might be coming, what do we mean by the precipitation? The precipitation results when the water droplet come together and form larger drop that can drop down. The atmosphere must have the moisture, sufficient nuclei present to aid condensation. Weather conditions must be good for condensation to take place. Products of condensation must reach to the earth. The water vapor condenses over nuclei to form teeny water droplets of size less than 0.1 millimeter diameter under favorable weather conditions. Nuclei are usually the salt particles or the product of combustion or the normally available in plenty. The wind speed facilitates the movement of clouds while its turbulence retains the water droplet in suspension. So basically, the different forms of the precipitation can be the snowfall or drizzle or glaze or sleet or hail. The precipitation is caused because of the different fronts which are formed. Maybe an interface between the two distinct air masses. Because of that, the precipitation is caused because of the cold air or the warm air when the front is created, and because of that, the precipitation takes place. Or there can be the orographic precipitation that when from the oceans, the moist or warm air rises, the moist air condenses as the air cools, and then because of the wind, that moist air moves towards the earth, and then the rainfall occurs, right? Or there can be the convective precipitations. So different forms of precipitations are there. So I hope the point is clear to all of you. about the precipitation. Beside the precipitation, there can be the cyclones. You might have heard the various, most of the time in the news, the cyclone has come. The tropical cyclones, which causes the heavy damages, and particularly during summer months, it originates in the open ocean at about 5 to 10 degree latitude and move at a speed of 10 to 30 kilometers per hour to higher altitude in an irregular path, derive their energy from the latent heat of the condensation of the ocean water vapor and increase in size as they move on the ocean. When they move on the land, the source of energy is cut off and it dissipates energy very fast and intensity of storm decreases rapidly. So therefore, it gives moderate to excessive precipitation over large areas of the order of, say, 1,000 square kilometers for several days or so. We can measure the rainfall by the different ways, by the rain gauges, like the non-recording gauges, recording gauges or self-recording gauges, or tipping bucket type, weighing bucket type, natural siphon type, telemetry rainfall. Nowadays, we use the radar measurement of the rainfall. Or sometimes nowadays, we are using the automatic hydrologic stations where the sensors for each climate variables are there, data loggers are there, and real-time transmission possible if it is equipped with the communication system. So this is how we deal with the important aspect of the precipitation. Then, of course, the evaporation is there. The evaporation process is basically the net escape of water vapor molecules from the liquid state to the gaseous state, constitute evaporation. And this rate of evaporation depends on the vapor pressure at the water surface and air above, air and water temperatures, wind speed, atmospheric pressure, quality of water, and size of the water body. The estimation of evaporation is of utmost importance in many hydrological problems. In the arid zones, this estimation is particularly important to conserve water resources. Exact measurement of evaporation from a large water body of water is indeed one of the most difficult tasks. The various methods used for the assessment of the evaporation are the empirical equations, like the various equations which are famous are based on the Dalton type equation or Mayer formula or Bauer formula. Analytical methods, like which are based on the water budget concept or the energy balance concept or the mass transfer concept, or the evaporimeter, like the class A evaporation pan, ISI standard pan, Colorado sunken pan, the US Geological Survey floating pan. I'm just giving you the overall idea. Of course, if you want to go into detail of that, you can refer any of the reading material on that. But just because you people are having the background of chemistry, you will appreciate that how we, what are the concepts used in the hydrology. Like the class A evaporation pan, it is a standard type of standard dimension pan where we put the water in the pan. Then after next day, we again pour the water in the pan and see that how much water we pour in the pan. And from there, we can identify that how much the evaporation is taking place in that particular area. So like that, we can measure the evaporation. Similarly, that evapotranspiration is basically is a combination of evaporation and transpiration. Transpiration is the process through which the water leaves the living plant and reaches the atmosphere as water vapor. And evaporation and transpiration considered together are known as the evapotranspiration. Right? So this also we can measure in the form of the potential evapotranspiration or the actual evapotranspiration. So we can measure this aspect also. So this is the land system which is important from the hydrology point of view. Second is the earth system. In the earth system, what we have is the land system is there, and from the land system we have the evapotranspiration or the surface runoff. From the land system, then it goes to the subsurface system. There is a connection between the land system and the subsurface system. And from the subsurface system, again, we can have the stream flow in the form of the springs, or from the subsurface system, it can go to the evapotranspiration, or it can go towards the aquifer system, that is the subsurface or the groundwater flow, or even in this process, we can have the process of the infiltration or percolation or upward movement of the moisture or exfiltration. The infiltration, as it is a very simple thing, that is the process through which water on the ground surface enters the soil. The rate of infiltration is affected by soil characteristics, including ease of entry, storage capacity, and transmission rate through the soil. So basically, the infiltration depends upon the infiltration capacity, or the amount of infiltration depends upon the soil type, the surface of entry, and the fluid characteristics. The various formulas we use for the infiltration rate, one of the famous is the Horton's formula, and in that we are basically talking about what is the final equilibrium infiltration capacity and how the infiltration varies. Basically, it varies in the form of the exponential form. The exponential decay is that e raised to power minus kt is there, and the k factor we determine for that particular place, and we can find out the infiltration rate. Right? So this is how the earth system is there, which is important from the hydrology point. Then the another important aspect which we use in the hydrology is the hydrograph. Very popular terminology which we use in the hydrology. Hydrograph is basically an integral expression of the physiographic and climatic characteristics that govern the relations between the rainfall and runoff of a particular drainage basin. It can be a flood hydrograph, it can be a storm hydrograph, it can be a unit hydrograph, it can be an instantaneous unit hydrograph. So many aspects of the hydrograph are there. And a stream flow or discharge hydrograph is a graph of or table showing the flow rate as a function of time at a given location on the stream. So like this figure is showing that, for example, if because of the storm, the water is increasing at a particular place, so the flow rate increases from A to B. Then because of the storm, the flow increases steeply. That is, the runoff from the catchment is coming in the form of from B to C. Then when this storm stops, then literally there is a recession. The delayed flow is coming from C to D. And then finally D to E, that is the base flow aspect. So this is also very important aspect in the hydrology. This was some of the aspect of the hydrology which I wanted to tell our students who are having the background of the chemistry, or some people who are dealing with the water. Then the second aspect which I would like to discuss with you is the sustainable development. What do we mean by the sustainable development, right? So basically, in order to have the sustainable water resources development and management, it should be cover the three aspects. One is the social aspect, second is the economic aspect, and third is the environmental aspect. That means any development which takes care of the social aspect, economic aspects, and environmental aspect, we call it as that development will be the sustainable. And beside this, any development that should be based on, that is the equitable. Equitable means that the development which is taking care of the social and economic, it should be viable, that is economic and environmental, and it should be bearable, that is dealing with the social and the environmental aspects, right? So this is the you can say the scope of the sustainability. Sometimes we call this, recently we use the terminology as the clean development mechanisms, or the CDM, or sometimes the sustainability, various aspects of sustainability we deal with as the like this. It is 4 aspects. Sometimes we deal with the 4 aspects, include the sustainable technologies also. This means that the social progress or the social aspect should be dealing with the stakeholder involvement, or the social equity, employment generation and capacity building, and the cultural heritage. When we are talking about the economic development, it should discuss, or it should cover the microeconomic efficiency, regional economy, and the infrastructure development. When we are talking about the environmental aspect or the environmental protection, it should deal with the biodiversity, water and land resources, like the pollution aspects, like the visual impact or the noise pollution or any other type of the pollution, And it should also discuss the sustainable technologies, because we are transferring the technology from the developed countries to our place, or maybe from any place. And then it should also have innovation. Unless until there is a factor of the innovation in the technology aspect, it cannot be sustainable. So these are the various aspects related with the sustainability which we should keep in mind. Then if you talk about the India's water resources, what are the salient features of the Indian water resources? As we know that population wise, we are almost 138 crore, that is the second largest in the world. Area wise, our area is about 3.29 million kilometers square, that is the seventh in the world. The average annual precipitation in India, we have the 1190 millimeter, which varies from 100 to 12,000 millimeter. You know very well that almost about 100 millimeter in the Rajasthan, desert of Rajasthan, and 12,000 millimeter in the northeast, that is the Chirapunji place. And the coefficient of variation is almost from 15 to 70. The total rainfall hours in India, we have almost near about 100. Nearly 80% of the rainfall occurs only in 3 to 4 months. And the number of rainy days are about 80 per year. And the average annual precipitation received in India is of the order of 4,000 kilometer cube. And if you see the seasons, we have the different seasons like the southwest monsoon from June to September, or the summer monsoon we call it as. Then the post monsoon from October to November, winter season from December to February, and the summer from March to May. So in India, we are getting the flow, basically precipitation and runoff. The three factors are important. And there are 15 parameters yearly forecast, the seasonal, fortnightly, or the drought or the flood. So basically in India, we have on the northern part, the snow peaks, and we have the coastal line. There is a Arabian Sea, there is a Bay of Bengal, and the westerlier winds are there. So these three are the major aspects or the sources of the precipitation. Almost 80% of the precipitation comes from the Bay of Bengal and 20% from the Arabian Sea. And if you see the water availability in Ganges, we have almost 28%. Brahmaputra has 30%, and rest have 3% or 4%, something like that. So the annual potential flow in India is 1869 kilometer cube. The average water resources, if you talk about, depending upon the 138 crores and the 1869 kilometer cube annual potential flow, the average water resources per capita comes out to be 1350 meter cube per person per year. As per international standards, that the critical condition is 1700 meter cube per person per year. So we are already in the critical conditions. The utilizable water resources in India, we have only the 1123 billion cubic meter, out of which 690 is the surface water and 433 is the groundwater. Whereas the total demand, total requirement is of the order of 1200 BCM. So we are already lacking behind the demand. So we have to think of how we can develop our water resources to meet our requirements. And another aspect of the India's water resources is that it is highly uneven in space and time. You have noticed that the number of rainy hours are very less, and we have to meet the requirements of the entire year on the basis of the only few hours in a year. Second point is the Brahmaputra, Barak, and Ganga system accounts for almost 60% of the total surface water resources. The western and southern regions experience severe deficit in water availability. Right? So this is the difference of the Indian water resources. So we have to think of, we have to develop the storages so that we can meet the demands of the people for the entire year. And if you notice that in India, the various river basins, there are different basin codes up to 25, the Indus, Ganga, Brahmaputra, Barak, and others, and so on. And if the various sub-basins dealing with these river basins are of the order of more than 100. And total number of watersheds in these rivers are more than 4,500 watersheds. So we have, each of the watershed has its own type of the problem. Then the second point is that in India, if you see the total length of the rivers is more than 35,000 kilometers. If you see that there are the Ganges and tributaries of the Ganges, and they are non-Ganges rivers. So if you notice that the Indus, Chenab, Jhelum, Kishan Ganga, Ravi, Satluj, Beas, these are the non-Ganges river, and Yamuna, Chambal, Betwa, Ganga, Gomti, Ghagra, Son, Gandak, Kosi, Brahmaputra, Luni, these are the Ganges rivers. And this slide shows the different major lengths of these rivers. Only I have shown the major lengths. And if you notice that all these rivers, the locations are given here. So almost 35,000 kilometer lengths. And out of these, if you think of on the bank of the rivers, there are large number of cities. I have listed here the cities which are having population more than 5 lakhs, right? Almost 68 cities are on the bank of the rivers. And it has been noticed that about 205 million people, which is almost 15% of the total population, lives in these 68 cities. And this population is almost 42% of the urban population. So if you see the color, that green color is the smart city, which has the concept has been given by this government recently. And this orange color is the million plus cities which are there. And these are the locations of these cities on the banks of the various rivers which are there. The out of the 68 cities, the smart cities are 44 and million plus cities are 46, right? So the cities which are smart as well as the million plus cities also, they are 35. So particularly in these cities, the problem of the water is more, because more and more people are there, and the carrying capacity of these rivers is not that much to take care of these needs of the people. So if you see the problems related to the water can be categorized under various conditions, like the quantity related, quality related, safety issues, the energy issues, and then the miscellaneous ones like the climate change, uncertainties, social and environmental issues like the greenhouse gas emissions, ecosystem imbalances, etc. For example, say quantity related, when we are talking about, every day we used to listen this in the news that the flooding of the various areas, like recently the flood in Chennai has come. Even the Tirupati faced very heavy flood few days back. Uttarakhand faced the flood. Even Brahmaputra faces the floods, and so on. We quite number of times we face the problem of the flood. Second is sometimes we face the issue of the drought, that people are not having the water, particularly during the summertime. If you see in the March, April, May, then you will find that even states are fighting for the water, and they are facing the issue of the drought. So these are the problems related with the quantity, the floods and droughts both. Then second issue is important is the quality issue, that even if the water is available, it may not be safe for drinking or eating. The drinking water supply scheme consists of the 3 components, like the source, treatment plant, distribution system, and all the 3 components are important to ensure consumer receives water quality compliant with the standards. And with the passage of time, the standards are increasing, the more and more awareness is there, and there are large number of parameters which are being covered. For example, say IS 10500 is very important code which gives the water quality standards. I will be just talking about that. Generally, safety of water is ensured at treatment plant, but no guarantee at the consumer tap. So we have to keep in mind, particularly the you people who are dealing with the chemistry, water chemistry is very important. The water quality deteriorates in space and time, and maybe due to internal decay or because of accidental contamination. and there is a need for proper water quality monitoring, direct or the inverse, and the monitoring itself. If you see the drinking water characteristics, the Indian standards which I just mentioned, that is 10,500 to 2012, it has basically characterized the parameters under different categories like the physical parameters, which are dealing with the color, turbidity, TDS, temperature, pH, odor, and taste. The chemical parameters like the BOD, inorganic elements, mineral oil, anionic detergents, nitrates, carbonates, sulfates, total hardness, phenolic compounds. Toxicological compounds like the cadmium, cyanide, lead, mercury, arsenic, molybdenum, chromium, nickel, trihalomethanes, pesticides, PCB, and pH. Then radioactive substance, there are guidelines for those also, the alpha emitters or beta emitters, or the biological characteristics like the bacteria, algae, virus, and protozoa. So for details, one can see the Indian standard. I can just show that code. This is the code for this 10,500. These are the details which are given in the code. So one can refer these details, which are the acceptable limit as well as the permissible limit for these different parameters are shown it here, like the toxic substance, like the radioactive substance, like the pesticides, the different type of pesticides, almost these 18 pesticides are there, then the bacteriological quality and so on. So these are the various parameters which we have to keep in mind. Because of the awareness, more and more parameters are coming, almost 67 parameters are there for the drinking water standards. Then the another issue related with the water quality is the river health. The main issues are the river health can be, one can study as the analogous to human health. Just as we are saying for the healthy person characteristics are like the clear skin, clear eyes, symmetrical features, expected reflex, the appropriate flexibility in joints and so on. So they should have the steady heartbeat, and so these are the characteristics of a healthy person. But what are the problems of the sick person? They may be having the blood pressure, the sugar, the weight high, and so on. So similar to this, we have the issues of the river health also, right? So we have to think of that this, but at present there is no holistic or scientific guideline for the river health or the river sickness due to pollution. So I emphasize this point that there is a need for the national policy on the river health in India. The characteristics of the river health are, should have, number one, that it should have a natural flow that varies in magnitude, frequency, duration, timing, and rate of change. The second is a river, healthy river should allow transport of sediment and nutrients. It should have the good water quality, that the temperature level or dissolved oxygen, salinity, turbidity, hardness, acidity, alkalinity, that are all within the natural range for that river and its species. And healthy rivers will also have minimal amount of pollution and toxics such as pesticides, nitrogen, phosphate, fecal coliform, and heavy metals. Then the healthy rivers should also have the strong and varied plant communities. It should have productive and diverse habitat, and aquatic insects are primary food and for many riverine species. So abundance and diversity of insect species can be a strong indicator of the river health. While the number of fishes and wildlife species will vary with each river, a diverse number of species is often an indicator of the river health. So in order to have a healthy river, the community in the river basin should protect it through wise management and community planning. So the various issues of concern for the river health are, number one is the e-flows, minimum and maximum or seasonal, aquatic flora and fauna, organoleptic parameters, physical parameters, inorganic and organic chemical parameters, and microbiological parameters. So sometimes we consider these under the different categories of the water quality parameters, like the organoleptic parameters, turbidity, color, visible oil, taste, and odors. The physical parameters like the flow, conductivity, temperature, resistivity, suspended solids, etc. Like the inorganic chemical parameters like the pH, dissolved oxygen, hardness, alkalinity, and so on. Or the organic chemical parameters like the BOD, chemical oxygen demand, the volatile organic compounds, and so on. Or the microbiological parameters like the bacteria, E. coli, total count, protozoa, algae, fungi, etc. There is another way of representing the water quality parameters in the river is like the organoleptic and physical, metals and ions, nutrients and related variables, pesticides and bacteria. So different researchers have given the different categories for the various water quality parameters for particular river health. Or in general, we have the river water quality parameters like the 19 parameters which we have. They are the optimal values or the target values. There are the acceptable values or they are the permissible values. So one should take the sample from the rivers and then they can take and check where those parameters are deviating, which of the parameter is good, which of the parameter is bad. So on that basis, one can identify the condition of the river health. For example, say the CPCB has given a one way depending upon the uses, like the class A, B, C, D, and E. Right? Class A is the best one, E is the lower one. So they have made the classification on the basis of these four parameters, like the total coliform organisms, the most probable number per 100 ml, the pH, which should be between 6.5 to 8.5, the dissolved oxygen should be 6 milligram per liter or more, or BOD, 5 days, 20 degrees should be 2 milligram per liter. So like that. Is there any problem? Can you hear? Hello?
Yes, sir.
Okay, sir. Okay, this.
Yeah, sir.
Yeah. So the different ways are there. Similarly, the Ministry of Environment and Forest guidelines are there that how to decide about the river health indicator. So some of the indicators which are used for the river health are like the scatter score index for water quality, index of water quality like the river health, overall index of pollution like the river health, chemical water quality index like the lake basin, or water quality index for the inland water. So like the ecological quality index is a function of the water quality index, Carlson Tropic State Index, and Simpson Diversity Index. So many people have given the different ways of representing the river health. So one can think of or one can go for the research in this direction. Then there are safety issues are there, like the natural hazards, man-made hazards, terrorist attacks, or the groundwater contamination. So those issues are also very important. Or the energy issues are there, like the environmental flows of the rivers, the greenhouse gas emissions, the sedimentation issues are there, or the submergence and the rehabilitation issues are there. I'm not going to detail of that because of the time constraint. So I hope these are clear. Then of course, the problems related to climate change, uncertainty, social and environmental issues like greenhouse gas emission or the ecosystem imbalance are there. Then the other thing which I would like to draw your kind attention is particularly the researchers. There is a good paper which highlights, or they have reviewed, that what are the unsolved problems in hydrology that would foster research in the 21st century. It has been noticed that there are 23 unsolved problems in hydrology identified by the community process in 2018. There are 7 categories like the time variability and change, space variability and scaling, variability of the extremes, interfaces in hydrology, measurements and data, modeling methods, and interfaces with the society. So if you go in each of the category, you will notice that what are the different problems which the researchers are paying attention, and you as researcher, you can think of that in which category you have the interest and you can carry out your research. For example, say the first category, time variability and change. Is the hydrological cycle regionally accelerating or decelerating under climate and environmental change? And are there any tipping points like the irreversible changes? So this is one of the research question. Second can be, how will cold region runoff and groundwater change in a warmer climate? That can be the question. What are the mechanisms by which climate change and water use alter ephemeral rivers and groundwater? What are the impacts of land cover change and soil disturbances on water and energy fluxes? The another can be the space variability and scaling, that what causes spatial heterogeneity and homogeneity in runoff, evaporation, subsurface water and material fluxes, and their sensitivity to their controls. What are the hydrologic laws at the catchment scale and how do they change with scale? Why is most flow preferential across multiple scales, and how does such behavior co-evolve with the critical zones, and so on. So several those issues are there, I have highlighted here. Then, like the variability of the extremes, how do flood-rich and drought-rich periods arise? Are they changing, or if so, why? Why are runoff extremes in some catchments are more sensitive to land use, land cover, and geomorphic changes than in others? Why and how, when do rain on snow events produce exceptional runoff? Or the interface in hydrology, like what are the processes that control hill slope, riparian, stream groundwater interactions? What are the processes controlling the fluxes of groundwater across boundaries? What are the factors contributing to the long-term persistence of sources responsible for the degradation of the water quality? What are the extent, fate, and impact of contaminant of the emerging concerns, and how microbial pathogens remove or inactivated in the subsurface? So all these are the areas of the research. One can pick up those areas and do the research. Or like the measurement of the data, how we measure the innovative technology to measure the surface and subsurface properties. What is the relative value of traditional hydrological observations? How can we extract information from available data on human and water systems? How can hydrological models be adapted to be able to extrapolate to changing conditions? How can we disentangle or reduce model structural parameter? Or how can the uncertainty in hydrological predictions be communicated to the decision makers? What are the synergies and trade-offs between the societal goals? What is the role of water in migration, urbanization, and dynamics of the human civilization, and so on? So these are the major parameters which are highlighted here. I think you should think of the questions and try to work for these. So these are the 23 major questions which are dealing with the hydrology. Then, after considering these questions or the live questions of the hydrology and the sustainable water resource development, how we can think of what is the connection between the hydrology and water resources management. So what we can think of, basically, to conclude my talk, I would like to figure this out, that we have to think of the designing the drainage systems. We have to think of the designing irrigation schemes. We have to think of the assessing impacts of natural and human-induced environmental change on the water resources. We have to think of the designing urban drinking water and sewage systems. We have to think of the determining agriculture water balance. We have to think of the assessing export of the sediment and nutrients from the fields to the water systems. Then we have to think of the buffers, designing the buffers. And overall, we should think of the determining the water balance for a particular regions. So we should be able to predict the floods. We should be able to estimate the demands. We should see the variability in the supply and demand, and how we can take care of the difference between the supply and demand. So those are the things we have to think of, if you say in the nutshell, about the hydrology and the water resources management. I think these are the points which I thought that I should share with you, so that I can provoke your thinking in some of the issues which are dear to you in particular areas. So I think with this, I will stop my talk. I invite the questions, if any, from the participants or any doubts or anything which they are thinking about these issues. I shall be very happy to answer those. So thank you very much for hearing me patiently.
Thank you very much, sir. This enlightening word should certainly help us to explore newer avenues in the field of hydrology. Now, this is a brief interactive session with Professor Kansal sir, and I request all the participants to take part.
Any question from the participant or any clarification or any comment if they have, I shall be happy to interact with the participants. And anytime, if particularly for the participants, those who are students, anytime if they want to interact, maybe after the lecture or at any time, my email address is there. They are welcome to interact with me. I shall be happy to clear their doubts, and in whatever way, if I can help, I shall be very happy to do that.
So we have that box. Please check.
Hello. Any question or anything? You are invited. If you can write the message, that also is good. I can read the message and I can respond to that if by chance if somebody is not been able to speak. Any question or any doubt? So otherwise, I hand over the mic to Dr. Swagda and the organizers if they have any point.
Any question?
Mudit join us.
Mudit?
Hello, Mudit.
Yes, ma'am. I have asked a question in the chat box.
Yes, I think Udit has asked one very important question. How does the chemical waste produced by the industries affect the agriculture fields? Yes, that is very important. I can give you one example and one incident. I have noticed in Gujarat, there was a common effluent treatment plant, and from there the waste which is treated, that goes in the Bay of Tambe. And that water, people use it for the irrigation purpose. So sometimes the waste of the industries is being used for the irrigation purpose. That is very dangerous. And people are not, those people themselves are not eating that food, but they just for getting the profit, they produce the agriculture produce and they sell it in the market. But that product is very dangerous. So sometimes when the industrial waste, which is being discharged in the rivers, and if that is used for irrigation purpose, that is very harmful. Similarly, if the, I think he's asking for the agriculture fields, so that I hope it is clear. But sometimes even the agriculture, this industrial waste, if it goes in the rivers, then at the downstream, we are using that water for several purposes. So that also is dangerous. I hope, Mudit, I have made this point clear.
Hello.
Yes.
Good evening, sir.
Yes, sir. Yes, sir. Thank you, sir.
Yeah.
Good evening, sir.
Yes. Yeah, good evening.
Dr. B.K. Das from Kokrajhar Government College.
Yes, sir.
Regarding the sustainable water resource management, just I want to know one clarification that in our state Assam, we are in a, that means in a, you can say one problem or some other way we can discuss. You know, Subansiri Hydel project. That project is going on, and the people of Assam are worried about that. That from this project, no doubt we'll get some electricity. Electricity generation will be there, but from that dam, there is every possibility of damage in the lower stream. So, what according to you, will this project be beneficial for Assam, or there will be a problem for the people of Assam?
Yeah, you see, the one thing is we should keep in mind that it should not be associated with the region. We should think of the benefits for the entire country, right? That is the one aspect. But yes, when we are talking about the country also, we have to think of that no area should be so much in the danger that it affect the life of the people, right? But no doubt in that whenever we are thinking of the development, naturally the people who are on the upstream side of the project, they get the losses, and the people sometimes who are on the downstream, they may get benefited, or even sometimes they also get the damage. So this is a very, I would say that the question that if you require the energy, and if you require in a better form of the energy, then you will require the hydropower project, because these are not only the energy purpose, they are for the several other purposes like the drinking water or irrigation or this. But this is definitely at the cost of some region for the entire state or for the entire country. So it is a complex phenomenon. One cannot say that whether a project should be stopped or should not be or it should be continued. So the decision maker, they have to think of in totality, right? So sometimes even in the family also, that sometimes the head of the family, they also give something more to the one boy and less to the other boy. So we have to think of in totality. I mean, one should not think of that, but that should be compensated properly, right? So sustainability will come only if you think of that. If you notice here that the social and environmental, and the word is there, that is the bearable. So we should, the development should be taking care of the bearable aspect, right? As well as it should be equitable, right? How it can be bearable and how it can be equitable, that one has to check it, and they should sit across the table that if you are getting something, I would say the losses, then how those losses can be compensated with the benefits, right? So then only the development should be sustainable. Otherwise, it will not be sustainable. Right? So proper compensation should be there, and we have to think of that all are members of the family. We should think in that direction.
Okay, sir.
I hope my point is clear.
Okay, sir. Thank you, sir.
Yeah. Then another question which is coming from Pooja Devi Bora is, oil seepage has been proved to be a serious issue for the marine water for last few decades. Can there be any permanent solution to it? Again, this type of problems are there, no doubt in that one. The environmental damage is there, and even the aquatic life is got damaged because of the oil seepage and those things. But permanent solution, one cannot say to that, but one has to think of if we are going for other form of the fuel. So if the in the marine water, if you are thinking of some other form of the fuel, then yes, we can avoid that one. Naturally, it cannot be totally removed, but it can be reduced. So we have to think of that such type of damage should be reduced, and it should be as low as possible. But complete removal, I don't think it is possible. Some risk is always there, right? So we have to bear with that bare minimum risk, but that risk should not be very high, right? So I think that I would respond to this question like that. I hope, is it clear, Madam Pooja?
Yes, sir. Yes, sir. Thank you so much, sir. Thank you for the information.
Yeah. Any other query or question?
Anjan Mondal has raised his hand.
I again thank you everybody for listening to me patiently. I hope some of the things may be of interest to you.
Thank you so much, sir.
Yeah. Thank you very
Hello.
much. Thank you
Hello.
very much.
Good evening, sir. Hello.
Yes.
Hello. Sir, I am Ami Devi from Department of Botany, sir. Good evening, sir. Sir, first of all, before questioning you, first of all, I pray to God for the eternal peace of his soul. Puspa Mahanta. So my
Yes.
question is that, sir, and the plant and water, there is a great relation between plant and water. Sir, I want to know how can we manage the water stress of plant body? Can hydrology help it to manage as a manage, sir?
Yeah, yes, I think in the hydrology, when I talked about the particularly the land system, the vegetation system, and you see that, notice that there is a flow of the water from vegetation system to the soil system, and from soil system to the vegetation system, and it
Yes,
is
sir.
related with the precipitation. So all the three are related, like the precipitation or the flow or the water connected with the vegetation and the soil system,
Yes, sir.
right?
Right.
So
Yes, sir.
so that we can supply the moisture from this to the plant from the soil system, and naturally the soil system gets the moisture from the precipitation.
Yes, sir. Yes. Yes, sir. Thank you, sir.
Thank you.
Yes.
Yes, I think some of my students from abroad are also there, from African countries. They found this. I appreciate your organizing this lecture, and several people from African countries have joined this. And yes, Mr. Gideon, there should not be any problem. I can share the PPT. I will send this to the organizers. If they want to keep it on their website or something like that, they can share it with them. Otherwise, if personally, if you ask me, I can share that with you also. Okay. Absolutely no problem.
Okay, thank you, sir.
So thank you very much. I think I can stop sharing now.
Hello, Sagata.
Any other question? Or we hello? Any other question from the participants? Okay, we should move on.
Yeah, my other student is also there, Edson Bundela. I think he is from Tanzania. He is also there. So several people are there from the African countries. Thank you everybody for listening me.
Thank you so much, sir. Well, now I request Professor Jugen Kalita, sir, kindly to address the participants.
Okay, good evening, everyone. Namaskar. It was really a wonderful presentation, so valuable to all of us. We all are getting the benefit out of it. Many of the questions were there, and all got the answers. I am so happy to listen to you, sir, Professor M.L. Kansal. So, with your experiences of many years and your hard work and research, you are discussing some of the very important issues. And I am sure that all our research scholars, young students, undergraduate and postgraduate, and also our faculty members, they are getting so many issues to work on. You highlighted 21 most important issues before us, and I am sure they will catch up with all those and they will devote their time doing for the nation as well as for contributing to knowledge in the field. I am so happy. Today we are paying great homage to our Puspajyoti Mahanta, who left us few months back, and the Department of Chemistry has been organizing this in a befitting manner, connecting a very reputed scientist, a professor of IIT Roorkee with international reputation. And as Professor has already said, that many of the members from across the globe, they are also joining us in our humble endeavor. As Sir has already mentioned, and I also can observe that chemistry department is one of the best department in the nation. They have a lot more contribution from Dr. Arunima and her team and her guide also, Professor K.G. Bhattacharya, to the entire knowledge field. I am very happy when Dr. Borthakur informed me that Dr. Arunima and her team has been working for this particular program, the national seminar, on a very important issue, hydrology and sustainable management of water resources. So it is very important for all the disciplines of science. I am from zoology. We talk about issues like what will be the environmental impact after making the big dam and Swansea River. And that question was put to you, sir. And you are replying in a very generous way and thinking about the future, thinking about the people as well as the culture. Because environment, culture, science, and people, we all are together. I am also grateful to all faculty members of Morigaon College because they are very hardworking. And sir, I am very happy to let you know that right from chemistry, all the department in the college, all the department, they have been developing very specific and very special certificate and add-on courses, like to add value to the graduates, because they will be getting graduate this certificate as well as some sort of certificates, which will be like certificate course, add-on course, value addition course. So all the faculty members, they are working together. And all the departments, they have already placed their syllabi as well as the courses in the GB. And in the governing body, we were so happy to see that not a single department was left out. All were putting their courses for the development of students. Sir, as this is the time of new education policy, and we always talk about quality. So therefore, in our very humble process of working for quality, you will guide us. I am sure that your guidance will make this department to grow more and more. I hope that chemistry department of Morrigaon College will be getting all sorts of help and support from you, your esteemed institution, IIT Roorkee, and Arunima and all other colleagues. As you have mentioned that Mahanta developed a collaboration long back, connection, developing connection and connecting the community is very important thing today. So I am so glad the chemistry department could connect to the level of the IITs of India, so famous in the world. Thank you so much, sir. And I thank all the participants who are devoting their very precious time asking beautiful questions, right from the faculty member to the students and the well-wishers. And also, I am glad that you are doing so good to us and hope that in future you will bless us. Thank you, sir, and thank you all. Thank you, organizers.
Thank you. Thank you very much, sir. It will be my pleasure to discuss with any one of you any issue or having the collaborations. And if I visit that place, definitely I would like to be in contact with you. And it will be my pleasure to visit your college also.
Yes, you are welcome, sir.
Thank
And I am sure definitely Arunima will invite you very soon in offline seminar or workshop.
Yes.
Thank you.
Thank you. Thank you very much. Namaskar. Namaskar. Thank you.
Thank you, sir, for your valuable speech. And also thank you for appreciating us. Now I request our Mr. Prince Chanda, our student, to offer the vote of thanks.
Hello, am I audible?
Yes,
Yeah,
yes.
yeah.
Yeah.
Yes. Good evening to one and all present on this auspicious occasion of Puspajyoti Mahanta Memorial National Webinar. I, Prince Chanda, on behalf of Chemistry Department, would like to owe the vote of thanks. I take this golden opportunity to thank our resource person, Professor Mithen Lal Kansal, for attending this webinar, sharing his vast knowledge, and making this event a special one. Sir, your presence itself is a great motivating factor for all of us. Thank you, sir. I extend my gratitude to our respected chief guest, Professor Jogen Chandra Kalita, for devoting his precious time and also for encouraging us to achieve many endeavors. Thank you, sir. It's my pleasure to thank our inaugurator, Dr. Leelakanto Borthakur, our coordinator, Dr. Ornima Sharma, and Dr. Ranjit Kumar Kalita, our joint coordinator, Dr. Mushid Iman, and Dr. Swagata Borua, for successfully conducting this event. I sincerely thank our technical coordinator, Mr. Bulbul Das, and all the non-teaching staff for glorifying this function. Last but not the least, I thank all the fellow students for your enthusiastic and active participation. Without you, this function would not be a success. Once again, I thank one and all wholeheartedly for joining this webinar. Thank you. Thank you so much.
Thank you,
Prince.
Sagota and Prince. You both of you are doing so well. Sagota,
Thank you, sir.
are doing so nice.
Thank you.
As well as our Prince also, he has given vote of thanks so nicely. And
Thank you so much, sir.
Thank you, sir.
Their students, their progression is very good. Chemistry department students and students of many other departments of Morrigaon College, they are progressing very well. They are reaching to very top ranking universities in the country, and some of them are crossing the border also. And it is because of the teachers, I know, and the support from the office people. As the principal is so dynamic, and principal is from mathematics, so he is always to the point. So I like that. And all the governing body members are also very supportive, very knowledgeable, like Professor Mohendo Ahum, who was the registrar of Central University Classroom. So, sir, they are guided by so many knowledgeable people, and they are getting good and hardworking students. I interacted with chemistry department students few months back when Puspajyoti Mahanta was there, and I saw the talent and the internal force and their urge for knowledge. And I am so happy to let you know And I wish that all students of that college will grow bigger and they will be brighter stars in our society.
Thank you so much, sir, for
Thank you, sir.
encouraging us.
অৰুণিমা শেষ কৰিব পাৰিবা নেকি? I think অৰুণিমাই কৰিব লাগিব।
Okay, sir.
Sagara.
Okay, ma'am. Okay, at last, I would like to thank all of you for giving your valuable time and to make this event successful. On this note, I want to conclude this webinar. Good night, all of you.
Yeah, good night.
Thank you. Namaskar. Namaskar.
Good night. We will see you again offline at Morigaon College.
Thank you.
Yeah, I hope
Thank you.
Purnima will invite